As with any design in Inventor, there are often a lot of approaches that will lead to the same end result. Even a simple design like you see here could be accomplished with a variety of approaches, but I will walk you through just one of the ways here. Regardless of the approach, one of the goals here is to fully constrain any sketches. And we are also looking to have the part match the orientation shown in isometric view. Let's get started. I'll begin by opening a new part file. Since this exercise is in millimeters, I'll go to the metric templates and select the standard millimeter template. The first step here is to begin a sketch for the extrude feature, but what plane should I begin the sketch on? In this case, I will choose the YZ plane because I plan on sketching a tombstone shape so that when I extrude it, the end result will match the orientation in the exercise in the isometric view. I will select the line tool and begin the first endpoint on the origin. I'll sketch the vertical and horizontal lines. The next thing I will need here is an arc. You could use any of the various arc tools in the Create panel, but since this arc will be tangent to this endpoint here, I prefer to use Auto Transition. To do this, I simply click and hold at the endpoint of the line. And when I move the cursor away, Inventor automatically transitions to the tangent arc. I'll pay close attention to the dashed inference line that appears before I place the other endpoint of the arc, so that it aligns with both the first endpoint and the origin. As soon as I release the mouse, the second endpoint is added, and Inventor switches back to the line tool. I'll finish the sketch profile by placing the last endpoint on the origin. Next, I'll add a couple of dimensions to fully constrain the sketch, and click the Finish Sketch button. To create the 3D geometry, I'll select the Extrude icon from the Create panel on the ribbon. The Extrude Property Manager appears. I'll set Distance A under Behavior to 10 millimeters. I'll also make sure the output is set to Solid and not Surface. When I click OK, the feature is complete, but did it meet all of the criteria? I'll click the Home icon on the view cube. And as you can see, the orientation of the part matches the orientation shown in the example. One thing I'd like to mention is that if you'd like to give your model real-world properties, such as a mass and density, you should set a material. To set the material for this part, I'll go to the Quick Access toolbar and click the drop-down next to Generic. For this example, I'll select Stainless Steel. Now, if I right-click on the part from the browser, select iProperties, switch to the Physical tab, and click Update, you can see the mass of the part listed here, along with other properties of the part.